Hello everyone, welcome you all for the video session on Module 3 Probability Distributions of your subject 18MAT41 Complex Analysis, Probability and Statistical Methods. So if you could just recall the last video session on probability distribution, we have studied normal distribution, right? You have seen the normal distribution and also standard normal distribution. Just recall the PDF of standard normal distribution, the standard normal probability curve. You can see here. What about the area under the curve? It is 1. Area on the either side is 0.5, and also we have seen the standard normal distribution table. It gives the area under the curve from 0 to z for any value of z, where z is greater than 0. So we have worked out few problems also by using normal distribution table, the standard normal distribution table. So in today's video session, we will continue with some more problems. So you have a copy of standard normal distribution table with you. We will proceed with the problems. So consider the problem. The mark of 1000 students in an examination follows a normal distribution with mean 70 and standard deviation 5. Find the number of students whose marks will be less than 65, more than 75, between 65 and 75. So see the problem, what is given. The marks of 1000 students follows a normal distribution. It is a normal distribution. So X represents the marks of the students. By data, what is given? The mean mu is equal to 70, standard deviation 5. You know the normal distribution. For the normal distribution, the mean is mu and the standard deviation is sigma, right? So according to the given data in the problem, mu is 70 and sigma is 5. So now given X is a normal variate, it follows normal distribution. So you have to convert this into Z, that is the standard normal variate, which follows standard normal distribution. What is the substitution here? To convert X to Z, Z is equal to X minus mu by sigma. You know what is mu, what is sigma? Substitute. So you get Z is equal to X minus 70 by 5. Okay, this is all about the given data. Now, what are required to find? What is the first question? Find the number of students whose marks will be less than 65. That is, you have to find P of X less than 65. So when X is equal to 65, convert that to Z. What is Z? 65 minus 70 by 5. That will be minus 5 by 5 or minus 1. When X is equal to 65, you will get Z is equal to minus 1. So according to the problem, you have to find P of X less than 65, or which is equivalent to P of Z less than minus 1. So P of Z less than minus 1. Less than minus 1 means it is from minus infinity to minus 1. You can see the curve. Less than minus 1. Less than minus 1 is minus infinity to minus 1, or it is the same as saying 1 to infinity. The area on the either side is same, right? 0.5. The curve is symmetrical. So area from minus infinity to minus 1 is same as that of area from 1 to infinity. So you can write it as P of z greater than 1. What is P of z greater than 1? P of z greater than 1 is nothing but P of z greater than 0 minus probability of z varying from 0 to 1. So if you go back to the figure here, probability of z greater than 1 from here to infinity is nothing but the total area from 0 to infinity minus area from 0 to 1. Right? Total area from 0 to infinity minus the area from 0 to 1 gives you the area from 1 to infinity. So what is P of z greater than or equal to 0? P of z greater than or equal to 0 is 0.5, right? Area from 0 to infinity, that is 0.5, it is fixed, minus this area can be written as area from 0 to 1 can be written as phi of 1. So go back to the table, check what is phi of 1. 0.3413, 0.3413. So 0.5 minus 0.3413. So it comes to as 0.1587. 0.1587. So this is the probability of x taking value less than 65. Probability of marks less than 65. Now the question here is find the number of students whose marks will be less than 65. Out of 1000 students, what will be the number of students whose marks will be less than 65? So that means you need to multiply this probability by 1000, right? Out of 1000, what is the number of students whose marks will be less than 65? You have found this probability of x being less than 65. Probability is out of 1. So you want out of 1000 students. So multiply this probability by 1000. So the number of students scoring less than 65 marks is 1000 into 0.1587. That comes as 158.7. So since it is number of students, we are rounding it off 159. Go to the next one. Find the number of students whose marks will be more than 75. So what are you required to find here? So first you need to find P of x greater than 75. P of x greater than 75. Then multiply that particular probability by 1000. X greater than 75. What is z? Z is equal to x minus mu by sigma. You have it here. X minus mu by sigma. X is 75. So 75 minus 70 divided by 5. So 5 by 5, that is 1. So when x is 75, z is 1. So P of x greater than 75 is same as that of P of z greater than 1. What is P of z greater than 1? What do you mean by P of z greater than 1? Just now we saw it is somewhere here you have 1. Area under the curve from 1 to infinity It is nothing but area under the curve from 0 to infinity minus area under the curve from 0 to 1, which gives you the area under the curve 1 to infinity. Right? So it is 0.5 minus 5 of 1. It's again 0.5 minus 3.4313. It's same as that of 0.1587. So number of students scoring more than 75 marks is 1000 into this probability 0.1587. That will come as 158.7. So as I told you, it is the number of students. So you are rounding it off. Your answer is 159. Okay, what is the next one? Find the number of students whose marks will be between 65 to 75. Number of students whose marks will be between 65 to 75. So first you need to find the probability of x varying from 65 to 75. X varying from 65 to 75. Find that probability. Multiply that by the number of students, 1000. Okay, now what is P of 65 less than x less than 75? So already you have found when x is 65, z is minus 1. When x is 75, z is 1. So it is the same as saying P of minus 1 less than z less than 1. So minus 1 less than z less than 1. So area under the curve from minus 1 to plus 1. Minus 1 to 0 and 0 to 1. So as you already know, the curve is symmetrical. The area under the curve from minus 1 to 0 is same as that of the area under the curve 0 to 1. So you can write it as 2 times the area under the curve 0 to 1. Right? Or 2 times phi of 1. What is phi of 1? Already we have seen here. Phi of 1. So that is equal to 2 times 0.3413. Simplify 0.6826. This is the probability of x varying from 65 to 75. You need the number of students scoring marks between 65 to 75. So what we do here is you multiply this probability by 1000. So you get 682.6 or equivalently 683. Okay, you have another problem here. In a normal distribution, 31% of the items are under 45 and 8% of the items are over 64. Find the mean and standard deviation of the distribution. Read the question carefully. In a normal distribution, it is a normal distribution, 31% of the items are under 45. 8% of the items are over 64. Find the mean and standard deviation. So you need to find the mean and standard deviation of the normal distribution. The mean is mu and the standard deviation is sigma. Right? So what is given in the problem? 31% of the items are under 45. Under 45. So P of x less than 45. 31% is probability is 31 by 100. So it is 0.31. 31% of the items are under 45. So P of x less than 45. Y less than is, it is under 45, below 45. and 31% becomes probability is 31 by 100. So it is 0.31. Similarly, the next one, over 64. So probability of x taking value more than 64 is 8% or 8 by 100, that is 0.08. So this is your given data. Only this is given to you. You need to find mu and sigma. So since this is a normal distribution, convert this into standard normal distribution by using z is equal to x minus mu by sigma. Standard normal variate is z is equal to x minus mu by sigma. When x is equal to 45, what is z? 45 minus mu by sigma, say that it be some z1. You name it as z1 for convenience. When x equal to 64, z is 64 minus mu by sigma, that is z2. Say that it be some z2. You don't know what is mu and sigma, you need to find it by using the given probability. Now, P of x less than 45 is 0.31. That means P of z less than z1. When x is 45, z will be 45 minus mu by sigma. P of z less than z1 is 0.31 and P of z greater than z2 is 0.08. That's what I have written here. You can observe P of z less than z1. z1 is 45 minus mu by sigma is 0.31 and P of z greater than z2 is 0.08. Now, you can observe probability of z less than z1 is 0.31. So, it is less than 0.5. So, z1 will be somewhere here on the negative side, right? This probability is less than 0.5. So, probability of z taking value less than z1. So, minus infinity to z1. So, it will be somewhere here, 0.31. Okay. Now, probability of z greater than z2 is 0.08. Greater than z2, so z2 will be positive, 0.08. Somewhere you have z2 here. So z1 is negative, z2 is positive. So this probability of z less than z1, probability of z less than z1, that is minus infinity to z1, can be written as probability from minus infinity to 0 plus phi of z1, 0 to z1. So that is nothing but 0.31. 0.5 plus phi of z1 is equal to 0.31. So what is your phi of z1? 0.31 minus 0.5, that is minus 0.19. Okay, and here z2 will be having somewhere here probability of z varying from z2 to infinity. That is nothing but probability from 0 to infinity minus probability from 0 to z2. So 0.5 minus phi of z2 is equal to 0.08. Hope it is clear for you. P of z less than z1 is 0.31. Since it is less than z1 is minus infinity to z1 is 0.31. Since it is less than 5, again this probability, less than 0.5 probability, so you will assume that z1 is negative. Okay, and this is from z2 to infinity, 0.08. So it will be on the positive side. So now you get phi of z1 is minus 0.19 and phi of Z2 is 0.42. Now you have the probability, you don't know what is Z1 and Z2. So refer the normal distribution table. Where do you get 0.19? 0.19. Refer the value, then find the Z value. 0.19, you have somewhere here 0.1915 probability, that corresponds to Z is equal to 0.5, right? So phi of 0.5 is 0.1915. Phi of 0.5 is 0.1915, and this is 0.42, 0.42, this is 0.4192, and this is 0.4207. So you can even take it as 1.4 or 1.41. So we will take only one decimal, 1.4. So phi of 1.4 is 0.42 and phi of 0.5 is 0.19. Phi of 0.5 is 0.19. So you have minus 0.19. So what you do is you take Z1 as minus 0.5. Okay, phi of Z1 is minus phi of 0.5. So Z1 is minus 0.5. Z1 is negative. And here Z2 is 1.4. Okay, here probability was given. You are required to find Z1 and Z2. That is the value of Z. Now Z1 is minus 0.5 and Z2 is 1.4. But what is your Z1? 45 minus mu by sigma, and Z2 is 64 minus mu by sigma. So Z is equal to Z1 is equal to minus 0.5, or 45 minus mu by sigma is minus 0.5, and Z2, that is 64 minus mu by sigma is 1.4. Or simplify this, 45 minus mu is equal to minus 0.5 sigma. 45 minus mu is equal to minus 0.5 sigma, or 45 is equal to mu minus 0.5 sigma. And this is 64 is equal to mu plus 1.4 sigma. So you have two equations with the two unknowns mu and sigma, right? Two equations, mu minus 0.5 sigma is equal to 45 and mu plus 1.4 sigma, that is 64. So two equations in two unknowns. Solve it, you will get the value of mu and sigma. Verify, you will get mu is equal to 50 and sigma is equal to 10. Mu is equal to 50 and sigma is equal to 10. So what is your mean? Mean is mu, that is 50, and the standard deviation is sigma, that is 10. So this is the required answer. We'll move on to the next problem. In a test on electric bulbs, it was found that the lifetime of a particular brand was distributed normally with an average life of 2000 hours and a standard deviation of 60 hours. If a firm purchases 2500 bulbs, find the number of bulbs that are likely to last for more than 2100 hours, less than 1950 hours, and between 1900 to 2100 hours. So go through the problem, write down what is given first. Distributed normally. The lifetime of a particular brand of electric bulbs is distributed normally. So it is a normal distribution. So average life is 2000 hours, standard deviation is 60 hours. So what is the mean of average life or mean of standard distribution is mu, that is 2000. Mean of normal distribution, not standard normal distribution. We are using normal distribution first, then converting into standard normal distribution. So mean mu is 2000 and standard deviation sigma is 60. So mu is 2000 and sigma is 60. What are you required to find? You are required to find the number of bulbs that are likely to last for more than 2100 hours. That is, you need to find the probability of x greater than 2100 and multiply that by 2500. Here P of x less than 1950 into 2500, and here 2500 into P of 1900 less than x less than 2100. Okay, you have one more example here. Okay, I'll explain this first. Then we shall move on to the next example. So mu is 2000, sigma is 60. So what is your standard normal variant? Z is equal to x minus mu by sigma. Substitute for mu and sigma. Mu is 2000, sigma is 60. So what is your Z? X minus 2000 by 60. So Z is equal to x minus 2000 by 60. So for the first one, you need to find P of x greater than 2100. So when x is equal to 2100, what is your Z? 2100 minus 2000 by 60. That is 100 by 60. It will be 1.67. So when x is 2100, Z is 1.67. So P of x greater than 2100 is same as that of saying P of Z greater than 1.67. So it is P of Z greater than 1.67. What is probability of Z greater than 1.67? 1.67 you have somewhere here, right? Z greater than 1.67. So 1.67 to infinity can be written as P of Z greater than or equal to 0 minus P of Z varying from 0 to 1.67. So probability of Z greater than 1.67 is nothing but probability from 0 to infinity minus probability from 0 to 1.67. So this area under the curve from 0 to infinity, you know already it is 0.5 minus area from 0 to 1.67, that is denoted as phi of 1.67. So 0.5 minus phi of 1.67. What is phi of 1.67? Refer the table. 1.67. 1.6 you have here. 0.07. So it is 0.4525. You have it here. 0.4525. So 0.5 minus 0.4525. Get the answer. What is the answer? 0.0475. 0.0475. This is the probability of x greater than 2100. What are you required to find? You are required to find the number of bulbs that are likely to last for more than 2100 hours. So to find that, you are multiplying this probability by the number of bulbs. So 2500 into this probability, that is 0.0475, that gives you 118.75. So but since this is the number of bulbs, we are rounding it off. It is 119. So you also have here P of x less than 1950. So when x is 1950, find z. Z is equal to minus 5 by 6, that is minus 0.83. Z is x minus mu by sigma, right? Convert it into z. Z is minus 0.83. So P of x less than 1950 is same as that of P of z less than minus 0.83. So probability of z less than minus 0.83, it is nothing but the area under the curve from minus infinity to minus 0.83. But since the curve is symmetric, you can write it as that is the same as area under the curve from 0.83 to infinity. Area under the curve from 0.83 to infinity. So which is nothing but area from 0 to infinity minus area from 0 to 0.83. So this area P of z greater than 0.83. P of z greater than 0 minus P of z varying from 0 to 0.83. Right? And this is 0.5. Probability of z greater than or equal to 0 is 0.5, as you already know. And probability of z from 0 to 0.83 can be denoted as phi of 0.83. So 0.5 minus phi of 0.83. So that is 0.5 minus, what is phi of 0.83? Phi of 0.83. 0.8, then 0.3, that is 0.2967. 0.2967. So 0.5 minus 0.2967, that is 0.2033. So probability of x less than 1950 is 0.2033. Therefore, the number of bulbs that are likely to last for less than 1950 hours is 2500 into the probability we got, that is 0.2033. 2500 into 0.2033, that is 508.25. So round it off. Since it is 0.25, we are writing it as 508 itself. Okay, what is the third one? Third one is to find probability of x lying in the interval 1900 to 2100. Probability of x varying from 1900 to 2100. So now if x equal to 1900, what is z? You calculate. X minus mu by sigma you have. So when x is 1900, your z will be minus 1.67. Verify this. And when x is 2100, z is 1.67. Okay, this is very simple. So what is probability of 1900? Less than x, less than 2900. That is equal to P of minus 1.67 less than z less than 1.67. So because of the symmetry, you can write it as 2 times P of 0 less than z less than 1.67. P of 0 less than z less than 1.67. That is equal to 2 into phi of 1.67. 2 times phi of 1.67. What is phi of 1.67? Refer the table. 1.6 then 0.7, 0.4525, 1.67, 0.4525, 0.4525, 2 into 0.4525, that is 0.905, 0.905. Therefore, what is the number of bulbs that are likely to last between 1900 to 2100? The number of bulbs, that is total number of bulbs into the probability of x varying from 1900 to 2100, that is 2500 into 0.905, that comes around 2263. So we'll consider one more problem. In an examination, 7% of the students score less than 35% marks and 89% of students score less than 60% of marks. Find the mean and standard deviation if the marks are normally distributed. It is given that if P of Z is equal to 1 by root 2 pi into integral of e power minus z square by 2 dz from 0 to z, then P of 1.2263 is equal to 0.39 and P of 1.4757 is equal to 0.43. So now read the question carefully. Somewhere you have normal distribution mentioned here. So it is normally distributed variable. 7% of the students score less than 35 marks. 7% of the students score less than 35 marks. So if x is marks scored by a student, 7% less than 35. So probability of x less than 35 is 7 by 100, that is 0.07. And less than 60, P of x less than 60 is 89%, that is 0.89. Find the mean and standard deviation. So that mu and sigma be the mean and standard deviation. So you need to find what is mu and what is sigma. So normal variate, convert it into standard normal variate by using the substitution z is equal to x minus mu by sigma. Now when x is equal to 35, what is that? 35 minus mu by sigma, let it be some z1. You are taking it as z1 for convenience in writing. When x is equal to 60, z is equal to 60 minus mu by sigma, let it be some z2. So you are given the probability. So P of x less than 35 is equal to 0.07 now becomes P of z less than z1 is equal to 0.07. So corresponding to x is equal to 35, you have z is equal to z1. So this equation will become P of z less than z1 is equal to 0.07, and this will be P of z less than z2 is equal to 0.089, 0.89. So P of z greater than P of z less than z1 is 0.07 and P of z less than z2 is 0.89. Now consider this. P of Z less than Z1 is equal to 0.07. As we have done in the second problem, Z less than Z1 is 0.07, can be written as 0.5 plus phi of Z1 is 0.07. P of Z less than Z1 can be written as 0.5 plus phi of Z1, that is 0.07. Or what is your phi of Z1? Phi of Z1 is minus 0.43, that is 0.07 minus 0.5, that is minus 0.43. And the second equality you have P of Z less than Z2 is equal to 0.89, which can be written as 0.5 plus phi of Z2 is equal to 0.89. Or what is your phi of Z2? Phi of Z2 is equal to 0.89 minus 0.5, that is 0.39. Take this 0.5 on the other side, it will become 0.39. Now phi of Z1 is minus 0.3. So the given data, what is given here? So you can observe here P of Z is equal to 1 over root 2 pi integral 0 to Z e power minus Z square by 2 dz. So this function we have taken it as phi of Z. We have used the notation phi for this. So phi of Z is this, then phi of 1.2263 is 0.39 and phi of 1.4757 is 0.43. Just the change in the notation, we used to denote it as phi for our convenience, but here it is capital P. Only the notation is different, but the function is same. So don't think this is the probability P which you are using. This is the same as that of function phi. So this is phi of 1.2263 is 0.39 and phi of 1.4757 is 0.43. What you have here is phi of Z1 is minus 0.43. Phi of Z1 is minus 0.43. So when is the probability 0.3? Phi of 1.4757 is 0.43. So what should be Z1? Z1 is minus 1.4757. So according to this data, Z1 is minus 1.4757. And phi of Z2 is 0.39. Phi of Z2 is 0.39. So what is your Z2? Z2 is 1.2263. Fine. So you will get Z1 as minus 1.4757 and Z2 as 1.2263. So now you have the values of Z1 and Z2. What is your Z1? Z1 is 35 minus mu by sigma. So 35 minus mu by sigma, that is equal to minus 1.4757. Z1 is minus 1.4757. But what is Z1? Go back and see 35 minus mu by sigma. So you will get here 35 minus mu by sigma is minus 1.4757. What is Z2? Z2 is 1.2263 or Z2 is 60 minus mu by sigma. So what do you get? 60 minus mu by sigma is 1.2263. That is what we have written here. 35 minus mu by sigma is minus 1.4757 and 60 minus mu by sigma is 1.2263. Simplify this. 35 minus mu is equal to minus 1.4757. 35 minus mu, cross multiply, minus 1.4757 sigma, or mu you can shift it to the other side, mu minus 1.4757 sigma is equal to 35. Simplify and then verify, and this you can observe 60 minus mu is equal to 1.2263 sigma. 60 minus mu is 1.2263 sigma, or mu plus 1.2263 sigma is 60. So verify both the equations. What we are getting here, mu minus 1.4757 sigma is equal to 35, and mu plus 1.2263 sigma is equal to 60. So you have two equations for two unknowns. What are the unknowns? Mu and sigma. You know how to solve two equations in two unknowns. Solve both the equations. You will get mu is equal to 48.65 and sigma is 9.25. So mu is 48.65, sigma is 9.25. Verify your answer. Thus, what is your mean? Mean is 48.65 and sigma is your standard deviation. It is 9.25. So here you be careful when you shift terms to the other side. Be sure about minus plus sign. 35, I have not written one more step here, the simplification part. So I will leave it to you. But verify this equation. 35 minus mu is equal to minus 1.4757 sigma. You are cross multiplying. Then shifting mu to the other side. Okay. Or you can bring sigma to this side. Shift 35 to the other side. It's one and the same.